and I'm one of the co-chairs of the Plant Nova Natives campaign. This is a campaign of over 50 organizations in the Northern Virginia area. We are not a 501c3. We are not an independent organization. We are a group of a partnership. And this evening's program is a partnership between the Audubon Naturalist Society, Plant Nova Natives, and the Virginia Native Plant Society. And we are graciously hosted this evening thanks to the Native Plant Society and Nancy Bears, who serves as both its statewide chairman and as the chapter president in her home jurisdiction of Prince William County. We have people who are in attendance from all of these 4 regions, perhaps from other regions as well. And in just a moment, Nancy has prepared a brief poll that we'll ask you to participate in. Plant Nova, I'm just going to say a couple of background, make a few background statements and observations before we get going. The Plant Nova Natives organization and campaign, which has been in existence for about 9 years, has launched in the last year, as most of you are probably aware, a particular campaign focusing on trees. And in the fall, we had a great celebration of trees with which we began. This program is part of that focus on trees out of the beginning and conviction that we can't truly care for those things we can't name and we can't fully understand. So it's I turned to an organization that has been formative in my own educational, in my own personal education in natural history field studies from the Audubon Naturalist Society in Chevy Chase, Maryland. And we'll hear a little bit more about the good works of ANS, or Audubon Naturalist Society. So for now, if everybody can please participate in the poll and answer these questions, we'll know a little bit more about you and your background. We're very pleased this evening that Bradley Simpson, on staff with the Audubon Naturalist Society for the past 4 years, and their restoration manager, has agreed to share a wonderful workshop and presentation with all of us. And we hope it'll help us get out and enjoy this special time as winter fades and the buds enlarge and we become even more aware of the woods around us. Nancy, how are we doing with our poll?
It looks like we have 80% of the people who
All
are
right.
online who have participated. So do we want to give another minute or so?
Sure, as people are still coming in, we still have quite a few people coming in. So the Plant Nova Trees campaign is funded entirely by donations. And if you or organizations that you may be part of are so minded to support the work that we're doing, we've been very busy distributing literature and also hanging tags on native trees in local nurseries and retailers. And I know that will continue this summer. There was always need for volunteer muscle in getting out and in doing that kind of thing. There are certainly opportunities that we can all take into our communities of all different sorts that we're part of in terms of educating people about our native trees. And we hope that this helps form up all of you who are participating this evening and preparing you for doing that kind of networking and carrying the torch forward.
So would you like me to close the poll now? We have 279 people who have participated out of 325.
Yeah, and I see we
Okay.
have a following from Maryland and the East Coast.
Okay, so I will end the poll now.
Thank you.
Last chance, everyone. Okay, so now we see the results. Most of us are from Northern Virginia. And let's see. And the majority of you heard about this through Master Naturalists. And we have a good spectrum of people on knowledge. I was reluctant to put the
Nancy, you muted yourself by accident.
that was by accident, sorry. So
Wonderful. Well,
okay,
we're glad.
So
we're
we've
glad-
shared the results and I will close out. Yeah, okay.
That's
Okay.
perfect. Thank you very much. So I'm going to remind everyone about some of the common Zoom courtesies. We'd like to ask that you remain muted as we do have several hundred people. We have over 500 people who registered for this evening. And a recording, as you may have noticed, will be made available. It will go up on the Plant Nova Natives, I believe the YouTube channel. Margaret, if I'm wrong, correct me. Margaret Fisher, our outreach, wonderful outreach coordinator, make sure that you all have access to the many resources that volunteers have pulled together and put on our website. So please do share news about our websites and those resources with the people that you know. And I would like to introduce Renee Grebe and invite her to say a few words about Audubon Naturalist Society.
Thanks, Joanne. I'm Renee Grebe. I'm the Northern Virginia Conservation Advocate for the Audubon Naturalist Society. I'm just going to share a quick few slides with you guys. Give me 1 second while I get this set up.
And while Renee does that, let me just ask that everyone, when we get to Bradley's presentation this evening, if everyone can turn off their video, that will give us a little bit more bandwidth because he's got beautiful photos to share with us all, but they eat up the electrons. Okay, Renee.
Joanne's got me covered. Everything on the slide you pretty much have heard, but first I want to thank you for being here because it is a gorgeous day outside, even tonight. So we're happy that you're here with us today. As you know, this is going to be recorded. So you're going to be able to get a recording of this later, and there'll be a link to it in your email at a later date. Please use the chat functionality for exchanging ideas or comments, but also for Q&A. We're going to have Q&A time at the end. And whatever questions you put in the chat box, we're going to be collecting throughout the presentation, and we'll pick from them at the end as we have time. And then, as Joanne mentioned, and lots of people in the chat box have mentioned, if you can stay muted during the presentation, that's great. And it will help speed up the slideshow if you have your video off. The speakers will have their video on, but everybody else, this is a great time to join a Zoom call with your video off, which I know all of us dream about. So that's great. Some words about the Audubon Naturalist Society. We are an independent Audubon Society, separate from the National Audubon Society, and we hope to inspire residents of the greater DC area to appreciate, understand, and protect their natural environment through outdoor experiences, education, and advocacy. You might imagine this ID class today as being done in the field, but it's pretty great that we're all able to do it in the comfort of our own home. And we have a vision to really create a larger and more diverse community of people who treasure the natural world and work to preserve it. And I want to introduce Bradley Simpson, who will be giving this talk on identifying trees in winter and the to-dos of twigs and bark. Bradley got a degree in environmental science, and policy with a concentration of wildlife ecology and habitat management from the University of Maryland, College Park. He was a research technician in urban plant ecology lab at University of Maryland, and was also a Chesapeake Conservation Corps member at ANS. And we were lucky enough to hire him as a restoration fellow, but he has now been promoted to ANS's restoration manager, managing the natural habitats at ANS's headquarters in Chevy Chase at the Wood End Sanctuary. And he's currently obtaining his master's at UMD in plant science and urban forest ecology. And we're really happy to have him here to talk to us today about identifying trees in winter. I'll hand it over to Bradley.
All right, thank you, Renee. I know the degree name is very, very long. There's just a lot of pieces to it, but I need to share my screen. We'll get that started. Okay. There we go. So like Renee said, there's a lot of, Renee and Joanne said, there's a lot of beautiful pictures. There is one video, so having videos off is really going to help with the number of people. But as everyone said, my name is Bradley Simpson, the restoration manager of Audubon Natural Society, about to talk about identifying trees in winter, the how-tos of twigs and bark. And even though it doesn't feel like winter today, without those leaves, it's good to understand what else there is to look at on our trees. So we already heard all of this. This is just the Word version of this. I will be sharing this presentation in a PDF format to the gracious host, and when the recording is posted, I'm sure that they'll send out this PDF version to you as well for a reference you can have going forward in your plant exploration. So identifying trees, there's lots of things to look at, especially more so in the spring and summer, but there's plenty of things to look at in the winter. We have characteristic features of bark, thorns, you can see fruit throughout the year and how it's growing. We use these characteristic features to go through dichotomous keys, and sometimes we skip those and use some fun apps like iNaturalist or an app developed by Virginia Tech Dendrology, which I highly suggest. I also highly suggest their websites and their fact sheets as a reference for when you're exploring your local trees. So I have a resources slide at the end, and this link will be on there as well. Towards the end of the presentation, we are going to go through identifying a twig sample with the dichotomous key, the winter tree finder that's pictured in the below right, a very popular and good suggested beginning key to use when getting started. Very cheap, and you can get it at our local Audubon Natural Shop at Wood End Sanctuary in Chevy Chase. Other tools, there's lots of other field guides. Picture to the right is a more technical key, key to woody plants. It includes basically any woody plant you'll come across west of the Mississippi. It's great. They have winter keys for lots of, they have a winter key, and then they have even more in-depth winter keys for some genera, though you'll find here. Got to have a hand lens. Ruler is important. A knife and pruner. We'll talk about a particular feature that you sometimes will need to look at called the pith, to see what it looks like, how it's shaped even. So having one of those is good. And sometimes you're just not able to get a good view of the twig without binoculars with those tall trees. You'll find I'm a pretty big stickler for taxonomy and using our Latin and scientific names. These names are universal throughout the world. Their common names can be a little confusing, but these really fancy Latin names can also be helpful in identifying our plants. Some of them tell you what it's going to look like. Magnolia grandifolia, big leaves, or Liriodendron tulipifera, tulip-like flowers. So Latin names are very helpful. They also tell us how things are similar. Things in the beech family, the Fagaceae, have leaves that turn brown and persist on stems. They also produce a nut, whether it's a beech nut, a chestnut, or an acorn. Olive families tend to have oppositely arranged leaves and stems, like the ash and fringe tree. Prunus, the cherries, have horizontal lenticels, and oaks, the quercus, have buds clustered at the ends of twigs, and it's pretty consistent. So understanding these characteristics and how they relate to each other makes it a little bit easier when looking at something, yeah, no matter what season you're in. We'll hear a lot of terms. I've already said a few. The ones highlighted are our big ones for today: pubescent, glabrous, terminus or terminal, axillary, leaf scar, and bundle scar. There's a beautiful book, Plant Identification Terminology, with lots of great illustrations. If you're really getting into more technical keys, I highly suggest having this book on hand. The glossaries are okay on most books, but having an illustration to show you what they actually mean by all these fancy terms is very helpful. I will say pubescent, in botanical language, there are like 20 different terms for how hairy is something. So definitely good to have this book with you. So important winter features, of course, twigs. Well, very important. Buds are on those twigs. You will look at our older trunks on the bark. Our fruit and some fallen leaves can help confirm a suspect identification. With wind and everything, it's hard to look at the leaf first and be like, oh, this is my tree, with how much leaves can move. But a good example, some very characteristic features on some species. Pawpaw has these nice flower buds with a vegetative leaf bud, the plated bark of flowering dogwood, and the clustered samaras of our tulip tree. So these are all individual fruits clustered together, sitting high up on the ends of the twigs of our tulip trees. No matter what season it is, what key you're using, the first thing they're going to ask you is, what is your leaf arrangement? Alternate, opposite, or whorled. Alternate means that at each point where a leaf occurs, only one leaf will occur there. Opposite, at every point a leaf occurs, there's going to be 2 leaves. Or whorled means 3 or more at each point a leaf occurs, which we call a node. So if you got an oppositely arranged tree or shrub, you're in luck. It's probably gonna be a lot easier to identify. Not as many of our even native or non-native species are oppositely arranged. They're more likely to be alternate. There's this little saying, mad vibes Lonnie, that you can use to kind of keep in mind what are your usual suspects for oppositely arranged specimens. We have the M is maples, the A is ashes, and the D is dogwoods. Vibes are our viburnums. Lonnie is Lonicera, the Latin name for our honeysuckles, both the vine and the bushes. Others are that you could include in this, in their taxonomic relation, is elderberry, the sambucus, which is in the same family as viburnum, the Adox acacia, or buckeyes and horse chestnut, the aesculus, which is in the same family as maples, the sapindaceae, or the soapberry family, all of which are oppositely arranged. So we can put in the chat if you like, but the opposite arrangement doesn't just occur at where the leaves occurs. It usually is pretty consistent into the actual structure of the entire branch. So you can see here the structure of its arrangement extends down all the way throughout this branch. Now, it's not always going to be this consistent. Trees are very good at deciding when a branch is going to actually be beneficial to them. If that branch is growing towards a lack of light, it will stop growth of that branch or even drop the branch in its entirety, because it's not going to be efficient in producing photosynthesis and their sugars. So it'll just decide to not put any more energy into growing that branch because they're not going to get a good return. So if they do this, sometimes you have some that are opposite and one that's alternate because it's missing. But if you're having this consistency of opposite, you can safely say that this specimen would be an oppositely arranged tree. And I guess on that, opposite is most always opposite, alternate is rarely ever opposite. So if it's opposite, it's most definitely opposite. So when you're looking at our twigs, I mentioned terminal. We have a bud at the end of the twig, or its terminal bud. Buds along the twig are axillary, and I'll explain why we use that fancy term axillary. Another term that you could see in keys would be lateral. So these would be lateral buds, and they sit above a leaf scar, the remnant of the tissue where the leaf was connected to the stem. Between these nodes where the leaf occurred is an internode. You can see twig scars left from the terminal bud scales from the previous year's growth. So you can count how many years. So this is a 3-year-old twig. All right. So yeah, that is our twig anatomy. Those are the main terms that we use. And this is just another look at that terminal versus axillary. It really just refers to the position of the buds along the stem. And this is what I meant with lateral. And an axil is the angle between the petiole, where the leaf stem, and the woody stem. It's that angle that sits in between there. So here's another view of it. So the nodes were the leaf, the axil is that angle. So this is an axillary bud, the angle created by the leaf and the stem. Fancy names for everything. And then within those buds, not only as their position, but also what structures are going to come from those buds. We have flower buds and leaf buds. Our flower buds are usually much more conspicuous. They're globular, they're spherical, they're round. On some species, flower buds open for leaf buds. So if you're walking around a forest right now, I'm sure you're probably seeing the flower buds of our spice bush, just very ready to pop and open and have those nice yellow male or female flowers that are going to attract insects and give way to nice red fruits in the fall. Our leaf buds are usually much more inconspicuous, they're less significant, and most of the time they are pointed, like in the example of our pawpaw. But there are also buds that include both the leaves and flowers. So examples are terminal buds in our horse chestnut, Aesculus hippocassinum. Also those big pointy bugs that you don't want to run into with your eye of the American beech, Fagus granifolia. Another good example are the terminal buds of sweet gum, liquid amber staphylococcus. Those are all buds that hold all the energy for the leaves and the flowers going into spring. So there's also another extra layer of terminal buds, and sometimes there's a bud at the end of a twig that is like a fake terminal bud, and that's why it's called pseudo-terminal. It's because it was an axillary bud that is now faking it's to look like a terminal bud, where there used to be a continuation of the twig here. So it was an axil because it was between the stem and the leaf, but then the end of the stem fell off, and now there's a stem scar and a leaf scar. So we'll have two scars at the end. There's actually quite a few species that we'll talk about today that have these pseudo-terminal buds. Some are more difficult to see, but in some cases, this feature can actually be quite characteristic and will be used in keys as well. And this is an example in Tilia, our lindens or basswood. So leaf scars and bundle scars. Leaf scar is the scar remaining on the twig after a leaf falls, where a bundle scar is the scar left by the vascular tissue, the xylem and phloem, the nutrient and water transport of the leaves. So this is a very characteristic leaf and bundle scar of black walnut, usually referred to as a monkey face shape. And we have the eyes and the mouth. So I will say big leaves mean big scars. So bigger leaves will leave bigger scars. So black walnut, as we may know, has a very huge pinnately compound leaf that can be over a foot long. So that is going to leave quite a huge scar. But smaller leaves like our red maple leaves are not going to leave as a scar that's as noticeable, and will definitely require a hand lens to see, especially if you want to look even closer at the bundle scars. Lenticels are raised pores in the stem of a woody plant, and they allow gas exchange between the atmosphere and the internal tissues. They can take up many shapes and sizes, and they can even be textured like that of spice bush or Lindera benzoin. You can even see the shadows from this picture, where the raised white rounded lenticels are very noticeable and protrude off the bark, where you can really feel it. We have our diamond shaped lenticels of our white poplar, Populus alba, which is a non-native. And then black cherry, our Prunus serratum, our horizontal lenticels. These little tiny ones, of course, when we think of our cherry blossom trees, we have much more pronounced long orange horizontal lenticels, which we'll see in a picture later, but this is how they look on our native black cherry. A lot more conspicuous when young, and then becoming a little bit more hidden as our bark transitions into the scaled and burnt potato chip look. Other protuberances and thorns, there's lots of them. There's lots of things that could come off a tree, most of which are to deter herbivory, or in the case of the honey locust, was to deter any damage from very old and extinct creatures such as the giant sloth. So we now see a natural variety of honey locust called Glittitia tricanthus vironermis that is now thornless, since they are able to survive because they don't have any pressure from the previous predator of this tree, which these huge thorns, tricanthus, triple thorn, protected them from. So a thorn is a stiff, woody, modified stem with a sharp point. So it comes from the stem. It will have vascular tissue, so it has xylem and phloem. We have spines, which are sharp pointed structures of a modified leaf or stipule. So that's where it derives from, and it's below the epidermis, so the outer layer of the trees. A prickle is a small outgrowth of the epidermis or bark, which does not have any vascular tissue. So a good example of a prickle is roses. Roses have prickles because it's just an outgrowth of the bark. So when the song said every rose has its thorn, it doesn't has its, every thorn has its prickle. Wings are a tiny flange of tissue, so like the wings of sweet gum or our non-native Guanamissa lattice burning bush. And then you can have a firm protuberance called a wart, like that in hackberry. And just to get a good look at the differences between thorn, prickle, spine, and then another one called bristle. So here's our Glittitia tricanthus. When they just start out, they're only single, they're not triple thorn yet. You can see this one starting to become more thorned. Our prickles of our non-native multiflora rose. Our spines, usually which occur with the leaf. So you can see that this is at a node. These are the paired spines of our black locust, Robinia pseudoacacia, and our bristle, a short, stiff hair or hair-like structure. So Rubus phenoclasius or wineberry has bristles as well as prickles. Another term that we see, or where we see bristle used, is at the ends of leaves in the red oak group. And just another look at wineberry too, and this can be, this characteristic I'm about to discuss can also be seen on our native Rubus species, our raspberry and blackberries, is that these bristles can actually be tipped with these little glands, and they're these sugary producing glands that are usually, they're a structure that are used to attract insects. Insects, especially ants, can have a lot of intimate relationships with trees and shrubs and vines, to the point where many trees have glands that secrete sugary substances, usually to attract ants, because ants can usually control or deter insects that might end up damaging the tree. So cherry is a good example of a tree that has lots of these sugary glands. So a little harder to see now. This is a picture I took a couple days ago. These glands are going to be much more active in the spring and summer when ants are going to be more active. So we're getting into our older stems, our bark. We have lots of different types of bark. If you really want to get into bark, there's a great book, Bark, a field guide to the trees in the Northeast. It is specific to the Northeast, so trees like persimmon will not be in this book. But it has a key that is specific to identifying trees only using the bark. I like to make sure to use other characteristics just to be certain in what I'm identifying, but it's pretty cool to really learn how to just look at a tree by its bark and just know in confidence what it is. So you can have smooth, unbroken bark like that of our beech trees. Young trees can, a lot of young trees are smooth and unbroken, and they mature to having a different type of bark. But for like that of the beech and the American hornbeam, Carpinus caroliniana, it will remain smooth and unbroken. We can have peeling bark, horizontally in curly strips like that of river birch or Betula nigra. The visible lenticels, here's our more characteristic lenticels we would see in our non-native cherries like in our cherry blossoms, and then vertical cracks and seams and what we would otherwise call smooth bark, like that of our hickories. So you can see these cracks and seams kind of creating these diamond patterns, and the hickories especially, they reveal this nice red inner bark. We can have scales like that of our black cherry. They're usually of similar size, and they are very easily broken off of the tree. And a much more thicker and stiffer version of scales, which we refer to as plates, would be like that of the flowering dogwood. Vertical strips can occur on some species where they're at least 3 times longer than wide, and a kind of intermediate aged red maple would have this bark. It's not too old, but it's also not young, where it would still have smooth unbroken bark. And then we have ridges and furrows, and there's different types of ridges and furrows. We have ones that intersect regularly. So these are the ridges and furrows of white ash, and they're constantly intersecting, creating these furrows, which basically is a term for a canyon of tree bark. So this is a canyon between the ridges, like a ridge and canyon of a mountain. So we have the ridges and furrows of our white ash, and they're all different sizes, those furrows or canyons. We have ridges broken horizontally, where we have lines breaking horizontally of our black oak, or ridges that can extend for over 12 inches or 1 foot before being interrupted, like that of our red oaks. We have these ridges that are occurring for a very long time without being interrupted by another ridge, forming those furrows. So even in winter, we do have some fruits that we can find. A lot of the ones that we find are dry fruits. They're either dry and indehiscent, that means it does not split open at maturity. So achenes, like an achene example would be a sunflower seed, or a nut like our walnut or acorns. They do not split open. Or we have a dry dehiscent, which means that it splits open at maturity. So a good example of this is anything that is a legume. Another example of a dry dehiscent would be a capsule. A capsule would be similar to what we see as a witch hazel fruit, or those of our catalpas. Even though they look legume or bean-like, they're actually a very long capsule. And when our fleshy ones, which we usually wouldn't find, we would find some older ones, except I think the best examples of fleshy fruits we would find would be that of our hollies. We find those throughout winter. We have drupes like the plumbered peach, which have the stone pit that we know of. So cherries are a good example of an edible drupe, but the stony pit does contain cyanide. Do not eat the stony pit. Blueberry is a good example of an edible berry. They lack that stony pit. And then there's even another one called pome, which have that central core that we know of, like apple core. So serviceberry, despite being called a serviceberry, is actually a very small berry like pome. And then you can have aggregates like our raspberries and blackberries, or the sweet raspberry, which is another name for our wineberry. So to get into more of our species, I always like to start with oaks and hickories. It is our main 2 groups of trees that make up the forest in our region. The oak hickory, usually an oak hickory mixed hardwood forest, depending on which physiographic region you are in. But so for the oaks, we have 2 main groups, the red oak group and the white oak group. They have characteristics that define their placement in these groups, and there's many species within each group. For the buds, both of them have the buds clustered at the twig terminus. White oak group buds are usually more rounded and variably pubescent, while the red oak group buds are usually conical and mostly glabrous. Just remember and pay attention to the fact that it says usually. There are always exceptions. Our plants and trees do not read the books and the rules that we make for them. So there's always exceptions. The bark of a white oak group tends to have a light gray, flaky or plated bark. An exception for this one would be chestnut oak or Quercus montana, which is definitely not light gray or flaky. It's definitely deeply ridged and furrowed and more red. And the red oak groups tend to be dark gray or brown with a richer groove texture. The biggest difference between the two that separates them is the acorn development. White oak group acorns only take one growing season to mature, only 6 months, and the red oak group acorns take 2 growing seasons to mature, 18 months. So developing acorns, little tiny baby acorns, can be found on the stems throughout winter. So here's a good example of our willow oak, Quercus fellows, with these cute little developing acorns on the stem, and these were taken in winter, so no leaves. And there you can really tell with these 2 little curly appendages at the bottom of them away from the stem, and you can see them here too, and more mature ones. So these are the developing acorns. So some of these will fall, some of these will still develop, so you'll have multiple year growth of acorns on one tree. So this again is our willow oak. So I'll talk about more in depth about 2 of our common oak tree species that we'll come across in our forests. We have our northern red oak. So again, these are all in the Fagaceae, the beech family. The beech family includes our Quercus, our oaks, our Fagus, our beeches, and then our Castanea, our chestnuts. So the northern red oak is our Quercus rubra. The leaf scar, so it's alternately arranged except for those twigs at the top, which are clustered, 3 to 5 on average, and they're conical and with little to no hairs, though we can see a little bit of white pubescence on the scales at the tips of these buds. Twigs are smooth with only some pubescence or hairs. The bark is dark and smooth, shiny when young, but becoming more ridged when mature and having these very long, uninterrupted ridges. Dry leaves, again, can help with identification. These ones will have bristle tips, so a hair-like feature extending. It's the vein extending beyond the leaf margin to form a bristle tip, which is a hair-like feature. And they can be variably shaped depending on where in the tree they are. This is our top canopy sunleaf versus our bottom canopy shade leaf. Our white oak, or Quercus alba, again, leaf scars are going to be arranged alternately along the stem, 1 per node, 1 at each point a leaf would occur. Clustered as well, 3 to 5, similar to the red oak, but the much more rounded. Twigs are mostly smooth as well, but we have a very light gray bark that can be very flaky as well as plated. So it'll be flaky towards the top and plated towards the bottom. And these leaves lack those bristle tips and are much more rounded. Again, they'll be similar. They'll be more deeply lobed in the top canopy as a sunleaf, or more shallowly lobed as a shade leaf in the lower canopy. This is the Maryland state tree. Oh man, now I'm blanking on Virginia's, but Maryland state tree is white oak. Flowering dogwood. Okay, so we'll I don't think flowering dogwood's in my presentation. We did mention it earlier with the characteristic bark. I've also heard that the flowering dogwood is the most dense wood of any tree native to our region. I heard that through working with volunteer groups at Woodend. I haven't really looked into it, but it would make sense as an understory tree to be very dense. Acorns, I talked a little bit about the acorn growth and development, but when they're mature, they can have a lot of variety. So again, this will be shared, this presentation in a PDF format will be shared with everyone. So this is just here as a reference, but this picture was taken directly out of Flora of Virginia. If you are really getting into, no matter where you are in Virginia or Maryland, you probably want to use Flora of Virginia. The most recent Flora of Maryland was done in the 1980s, and I guess we're actually in the 50th anniversary of the Flora of Maryland. So you definitely want to use the Flora of Virginia. If you're Pennsylvania, you have your own book, Flora of Pennsylvania. So to move into our hickories, which are in the Juglandaceae, the walnut family, we have our mockernut hickory, Caria tomentosa. So this is a good example of when the Latin name is helpful. Tomentosa meaning densely hairy. Alternately arranged leaf scars, 1 per node. You can see the hairs here too, even extending to the bud. Terminal buds are ovate, pubescent, and yellowish green. Ovate meaning egg-shaped, so wider at the bottom where it attaches to the stem, becoming less wide as you move up. Twigs are very stout, very thick. The bark is tight, eventually becoming deeply furrowed. The nuts are not winged, so the nuts inside the husk, and the husk usually split all the way down to the base, like you see here. You can find the leaf rachis, which I'll explain a little bit more in depth soon. On the ground, it is also densely tomentose. You can feel the hairs coming off on your fingertips as you pick it up. Bitternut hickory, Caryocortiformis, alternately arranged as well. We have some pretty long terminal buds that are scurfy. So another word for a type of hair covered with small brand-like scales, and valvate opening by valves, so two bud scales, and are bright sulfur yellow. The twigs are very slender, so a lot less stout than that of the mockernut hickory. Similar bark. The nuts are obscurely angled, but the husks are splitting incompletely into 4 valves. So you can see it doesn't go all the way to the base, but this one goes a little bit further on the husk. And this is the nut inside. So again, here's some variability of the hickory nuts from Flora, Virginia. So when I mentioned the rachis is the remnant. So this is the rachis and the petiole of a compound leaf. So it means that a leaf is separated into leaflets. There are no buds between our leaflets and our rachis, or between our petiolule and our rachis. A petiolule is just a petiole of a leaflet. So it's a compound leaf that are common in hickory and walnut leaves. And the remnant of this rachis can be found on the ground after the leaflets fall off, and it can help you with identifying your tree. So like I said, the Carytomentosa, this leaf stem is very hairy, and that leaf stem of the black walnut is very long and usually curved. So this is a picture of a black walnut. This is a regular printer sheet of paper, 8x11. You see how long it is, and it curves down. So you can find this on the littered around a black walnut tree. So black walnut, of course, is in the walnut family, the Juglundaceae. Its leaf scars are also arranged. The buds are very large and pubescent. The twigs are very thick, like that of the mockernut hickory. Bark is thick, very deeply ridged, and it's brown to nearly black. Though I've seen some young black walnut trees that can have a more gray bark. And of course, we have fruit as a walnut. So this is our very large 240-year-old black walnut at Wood End, which you'll see a nice picture of in summer at the end of the presentation. So we're going to go into talking about a variety of different tree species that are common in our area. So the first is red maple in the Saphidaceae, or the soapberry family. So these are one of our oppositely arranged species, the M of Mad Vibes Lonnie. The twigs and buds are very red to reddish. The bark on young trunks are smooth and gray. They begin to separate into vertical strips, and then the older trunks become rough and plate-like. And when we compare to silver maple, because they can have a lot of similarities, the leaf scars are, of course, are also opposite. They can be a little bit more reddish brown to somewhat orange, but if you are able to get a fresher twig and break it, at least in my experience and in my opinions, more subjective, but the twigs do not smell great when you break them, whereas the red maple is not really going to have any scent to them or any aroma. I will not compare it to Tree of Heaven, but it does not smell great in my opinion. And a similar bark, light gray, smooth when young, but these become a little bit more flaky than that of the red maple. And then they separate into large plates as it gets older. Sugar maple, luckily does not really look like our other two trees in winter. The leaf scars are also opposite, but the terminal buds are more of a brown to purple and a lot more sharply pointed compared to the more spherical globular shape of our buds in the red as silver maple, and the twigs tend to be more conspicuously brown rather than a reddish color to them. And our bark, instead of being definitely gray, it's more of a gray to brown, and vertical striping becoming furrowed with age, instead of plated. It could be plate-like, but it's a little bit different, especially if you're able to see the buds, because they're a different shape and color completely. But you will have to, this is where you can get confused with Norway maple during this time of year. I always put this tree in here, especially because it's very common at Wood End after years of site history of having a Japanese garden at Wood End. The Japanese maples are always good to know how to identify. Their buds are very interesting because they usually end in a pair of buds at the tip, and these buds also have this tan fuzzy fringe at the base of them. They're usually red to green and very slender and smooth, the twigs, and the bark is smooth light gray with its vertical striping, and sometimes referred to as cat scratch bark. And the leaves, instead of falling as like a whole leaf, they curl up towards the top. So curl up towards the top and then they'll fall off. So you'll have these like really curly leaves on the ground littered below a Japanese maple. So at Wood End, at least in the recently, 25% of the time you would point at a tree, it would be Japanese maple. Gotten it down to about 19% of the time now. So moving on to our elms, which are in the Olmaceae, the elm family. We have American elm. They're alternately arranged. The buds can be smooth or hairy, but they are two ranked, so they occur 180 degrees around the stem from themselves. So we have the bud here and 180 degrees around. We have another bud, and because of this two ranked feature, it creates this stem that zigzags. The twigs are somewhat drooping at the end, but mostly smooth. The bark is gray and flaky. Younger bark is very squishy to the touch. You can especially notice this on humid days. You can just like really push into the bark, and most of the time I really don't think of bark as squishy, but it is very much so in our young elms. And if you were to remove some of that outer bark layer, you would find an alternating red and white color. Kind of pictured here, this is from the bark book. So it has an alternating red and white color, which is different from our slippery elm or Ulmus rubra, which its inner bark would be only red, lacking that alternating white-red coloring. I couldn't find a picture of that one. It's not in the bark book, and not many pictures of those online, and I don't have like a good slippery elm to go to when I need pictures of it. Though I did find one day at Lake Artemisia near College Park. But another difference that they can have, despite also having alternately arranged two ranked buds with zigzag stems, is that their buds and the ends of the twigs are usually much more densely gray, hairy. So you can see this pubescence here creating this gray color on the stem. Otherwise, other than the inner bark being just red, the other characteristics being soft and squishy and scaly, becoming more ridge and fur with age, is similar to the American elm. So we have our black gum. This is Sylvatica of the Tupelo family and the Musaceae. Our leaf scars are also alternate. Our buds are very small and red. Our twigs have many curved spur shoots. So spur shoots are these small twig growths where we just have them growing slowly, and they usually only end in one terminal bud. And they're small, they're curved, they're almost finger-like in shape, and they're usually 90 degrees off from the stem. And the branching, even the branches coming off of the main trunk occur in a very perpendicular fashion. So you can see this 90-degree branching quite consistently throughout each tree. And when you're looking at the trunk, you'll notice it's very characteristic plated bark that is akin to the scales of an alligator. Another one with similar bark to that, the black gum, is the persimmon, Diospyros virginiana, and the Ebonaceae. Our leaf scars also alternately arranged. The buds are very triangular and kind of protrude off the stem, so you can see them kind of coming off. There's silhouettes as you look up. But I think there's nothing else more characteristic than this, than its bark. Even at a very young age, that plated structure can be seen, and it just becomes even more apparent as it matures. And on younger ones, you can see the inner bark in its orange color. So these are dioecious, so you have separate male and female individuals, like that of our sassafras and spicebush. So when you look for it flowering, you can look for the stamens or the pistil to see which one you have and which one you need to come back to in the fall for its fruit. So yeah, this one is an example that has a twig scar. So this is the leftover of a twig. So this is a pseudo-terminal bud. This is a twig that had the rest of the twig that has died and fallen. And now this axillary bud is faking and acting like a terminal bud. Tulip tree, I always will call it tulip tree. I'll never call it tulip poplar, even though I will most of the time call it a Liriodendron tulipifera. But it is not a poplar. Poplar insinuates that it's related to the Populus genus and the willow family, the Salicaceae. But it is not. If you were to see the flower, you would know that that flower is definitely not like that of any of our poplars and willows, poplars and willows have catkins, a very inconspicuous flower. Things in the magnolia family have these very conspicuous and insect attracting flowers, and that of the tulip tree attracts the tiger swallowtail when they come out. So our tulip tree is in the magnolia family, the Magnoliaceae, much more closely related to our southern magnolia than it is a poplar. Our leaf scars here are also alternately arranged. A feature that is distinctive in magnolias too is the stipular scar that encircles the entire twig. So this goes all the way around. At each point, a leaf occurs, usually sitting right above the leaf scar at the top of it. They have a very long duckbill shaped purple terminal bud, with the vegetative buds along the stem being more inconspicuous. So this holds both flowers and leaves. The trunks are very straight. Mature bark is brown with intersecting ridges. Young bark is gray with these white vertical lines. And the flowers, those nice, big, beautiful orange flowers, give way to clusters of samaras. These are winged seeds that fall in a helicopter fashion, similar to that of the seeds of our maples. And these are persistent on the tops of the tree throughout winter. You can see plenty of birds feeding on them on your lawn. We have our American beech, Fagus grandifolia, leaf scars alternate. Very, very long, sharply pointed, slender buds that have they have separate male and female flowers as well as leaves, all held in that bud. So it has lots of energy. So they're much bigger. Bark smooth and gray throughout its lifetime, brown leaves persisting on the stems through winter. Our black cherry and the rosaceae, the Prunus aurotna, leaf scars alternate as well, very small buds that are red to green. Twigs reddish brown and glabrous, lenticels being small and white at that point. Bark, this is a somewhat older stem, but you can start to see the horizontal lenticels starting to elongate and become horizontal, and then they give way to this burnt potato chip scaly look, where the lenticels become more inconspicuous. Sassafras albidum, in the laurel family, which is the same family that spicebush is in, Lindera benzoin. So they both have a spicy, sweet aroma when the twigs are broken or scratched. Also dioecious, so have separate male and female individuals, and both are host plants for the spicebush swallowtail. Their buds and twigs are very green and very glabrous and glossy and smooth. The bark is deeply furrowed when mature, and has a very obvious reddish inner bark. Sweet gum, liquid amber staurosa in the sweet gum family. Not on every stem, but on a lot of the stems, you'll get the winged feature that I mentioned earlier, one of the types of protuberances. The bark is rough and corky when young and becomes shallowly furrowed as it ages. We can find the remnants of the aggregate seeds. So these are an aggregate fruit. So there's many, each of these little things is a seed, has a seed in them. And they have big terminal buds holding the leaves and the flowers for the spring. Hackberry, Celtis occidentalis, and I was very intrigued to find on the floor of Virginia to learn that this is actually a tree in the hops family in the Cannabaceae. So very related to hops and hemp and our invasive Japanese hops, Humulus japonicus. And we mentioned the wart protuberance here. So you can see the warty structure in the hackberry that persists throughout its lifetime. Has a very slender, somewhat zigzag twig. And they also have a pseudo-terminal bud. But I think the most characteristic feature here is its warty protuberance on the bark, occurring even at a young age, and again persisting and just becoming more noticeable as it matures. American sycamore, hard to not talk about our Platanus occidentalis and the plane tree family. I think our most obvious feature here is the bark, the shreddy bark that reveals a white and sometimes red inner bark that it becomes just you can't miss it in the winter. They just pop out. They also have a stipular scar and it encircles the entire leaf. The leaf scar encircles they have a big leaf where that scar encircles the entire bud. They do have a small stipular scar too. And then we'll see hanging fruit capsules drooping from the stems, and these are aggregates as well. So there's many seeds hidden within there. They also consist of a pseudo-terminal bud. But you can see the leaf scar going all the way around the bud, the large buds. Flowering dogwood, I do have it on here. Look at that. So I do have Virginia state tree, Cornus florida, and the Cornaceae. The many trees on here, so I sometimes forget which ones I've decided to add because I've decided to take a lot, leave a lot off, and those are very difficult decisions. The easiest thing to look at here are the buds. We have two distinct types of buds, are vegetative, very inconspicuous, sharply pointed leaf buds versus our onion-shaped flower buds. Our scaled bark that becomes a lot more plated with maturity. Our ends of the twigs of our flowering dogwood are curved upwards with that onion sitting right on top, and they tend to be this purplish color. Pawpaw, we talked a little bit about it. We have our globular fuzzy flower buds here and a long vegetative bud here. These are interesting because the buds are said to be naked because they lack scales. So there's no protective covering or scale over the buds. The bark is light brown, generally smooth with these wart-like lenticels, all these lenticels here. And they're rhizotomous, so you usually see a nice big clonal individual occurring when you experience it. And then it's our last one before I just go into a key practice. We have our northern Catalpa speciosa in the Bignonia family. So this is more closely related. So this is the Bignoniaceae. It's more closely related to our trumpet creeper, Campsis radicans, than it is any of our legumes. Technically, Catalpa is more Midwestern. So there's two species. There's a northern and a southern. And they're technically not native, at least to Maryland. They might have some overlap in the range in Virginia, but they are technically not native to Maryland, but they are still have quite an amazing flower and are very interesting. So they are an example of a whorled tree. So at each node, they have 3 sunken buds. So you can see that the leaf scar is sunken and goes into the stem, which is very strange. We haven't seen something like this throughout this presentation. They do not have a terminal bud, which is also interesting. So instead of just having a pseudo-terminal, this one just does not have one. And then you get these long bean-like capsules found hanging from mature individuals. And from what I have found, differentiating between the two Catalpa species is quite difficult, and I have not even been able to do it with high confidence. So now we're going to go through a key practice just to solidify the need and the usefulness of using a key and we'll just be using the winter tree finder. So here's some pictures of what we are going to identify through this little practice. So we have our bark, our twig, our growth form is definitely a tree, our twig, and more close up of the bark. And we'll have a video of one of the bark features coming up shortly. So in the winter tree finder, it asks us first if the tree is a conifer and needle bearing. We definitely do not have needles. We are lacking any needles, which tells us that our tree is deciduous and not a conifer. Though there can be some confusion in this one with larches being what we would call deciduous conifer. And then the second question, once you decide it's not a conifer, is whether or not our leaf scars and buds are alternately arranged. We have only one scar at each node, so this is an alternately arranged tree. How thick is our twig? Is it over or under 1/2 an inch? It is under 1/2 an inch. Yeah, I usually like to measure the 2nd or 3rd year's growth here. Sometimes the twig definition or what they're referring to as a twig can be a little bit confusing. So you wouldn't want to measure like a really thick branch, but 2nd or 3rd year growth is probably suffice. It's asking if we have anything with that fits into this long feature, which when we look at it, we can determine our terminal and axillary buds are of equal size. So I think this is trying to see if we have a walnut or a hickory and telling us that if we don't have these characteristics, we definitely don't have a walnut or hickory. So now we're asking if our buds are clustered. They definitely are. So we can follow this illustration here. And if we were to have raised lenticels that become horizontal on older parts of the tree and 3 vein scars, so bundle scars on the leaf, we would have a pin cherry. We definitely don't have horizontal lenticels. These are our vein scars. I'm pretty sure this is the pin cherry, and we definitely don't have those lenticels or what they describe as 3 bundle scars. So we definitely do not have a pin cherry, but we know it's an oak. Now it's really asking to separate the red and white oak group. We have bark that is gray and flaky, which matches with the white oak group here in the top part of our key. If they are rounded or pointed, so we have more rounded buds. They don't come to a conical pointed shape at the end. And they're asking if we can easily rub off a handful of bark scales and if our bark is furrowed. So pretty easy to rub off the scales. So we can follow the first one up here. The twigs are smooth and not covered in a cool orange brown down. Down again is another word for hair. We definitely don't have that. They're pretty smooth. Post oak, if you do see young twigs, you can definitely see that very conspicuous orange brown pubescence. And then we're now separating between a white oak and an English oak. We have some 90-degree right angle branching, pale tan leaves that persist in the winter, and the fact that this was found, even though there's houses there, was found in a more wooded landscape. So that would be that of our white oak. So we have identified a white oak going through winter tree finder. And again, there's lots of other keys that you can use going forward. One I didn't mention, that's another great option, is Harlow's fruit and twig key. That's a great winter key to use, as well as the munchers I mentioned earlier, which has winter keys within it. Or in the bark book if you really just want to look at bark all day. So resources I use, the winter tree finder, of course, the bark book, munchers, which I just mentioned. The one that's not on here is the Harlow's fruit and twig key. Florida, Virginia, you can get the book or the app. Then Virginia Tech Dendrology and Go Botany is where I got a lot of my additional information. So you can, so this is like the picture I mentioned earlier. This is the big 240-year-old walnut. where this driveway was designed to go under when our mansion was built. You can take tours here. I'm the one who leads and organizes the tours. We have on a variety of topics of tours, trees, natural habitats, and our formal native plant gardens. That on all three of these, we'll talk about stormwater best practices. Natural history field studies certificate program is something you can do where you take a variety of courses to earn a certificate, and I teach some of the courses through there as well. If you weren't able to guess it, it is Tree ID. Those are what I teach in summer and in winter. ANS Naturalist Hour, so similar to these, but we do a few every month. You can email me for more information if you want to find more information on our tours. The link is here. Again, this presentation should be shared with everyone, so you'll have access to this information later. So that is the end of the presentation. Thank you all for coming, and I will happily answer questions until 8:30.
That's great. Thank you, Bradley. We did get a bunch of questions, and of course, they started early. So one of the first questions we got from Joe Dombia was, what happens to the winter buds after the winter?
So the winter and spring, so the buds are going to open in spring. They're going to push out all their energy into leaves or flowers, leaves or flowers or both. And then throughout the summer, the twigs are then going to form new buds with the energy they've been creating and storing from the new leaves they put out. The buds will sit there until winter, until they open again. It's just this continuing process of forming new leaves, forming flowers to create fruit, gaining more energy to create more buds, and then it's just a continuing cycle for tree growth.
Excellent, thank you. Another question we had was from Kara Shirk. Are the horned or thorns and prickles more often found on invasives?
I'd say that you will, if it's invasive, you are likely to find one of those thorns, prickles, or bristles, or protuberance, period, just because they do aid in its ability to evade herbivory, not only just not being a species that evolved with our native herbivores, being herbivory resistant does assist it a lot. So I wouldn't say that it's necessary for an invasive. We do have a lot of natives that have the same features. We have native roses with prickles, native blackberry and raspberry with prickles. The thornless honey locust and the black locust are native as well. I think it's just a pretty consistent feature on plants that have been able to evolve to evade herbivory. And some like to make the compounds that herbivores don't like that of spice bush. I find plenty of invasives without any protuberance, and they just deer just don't like to eat them. A lot of our non-native viburnums are good examples of that.
I will say I was in Hawaii once, and someone pointed out to me their native greenbrier, which has no thorns because it never needed it, but it looks exactly like our greenbrier. I thought, what a heavenly plant that is. Mary Alexander asks, is a characteristic of mockernut that twigs grow up and then out, looking kind of witchy?
I have not been familiar with that specific characteristic in identifying mockernut. What I usually hone into when I'm identifying a mockernut is finding that rachis below a tree and seeing how hairy it is. I do not know I'm not familiar with the feature in which you are referencing, unfortunately.
Mary had a second question too, which is, can you describe the look of the bark on an elm that suffers from Dutch elm disease?
I don't think the bark of an elm will look very different if it reaches it. So throughout the maturity of an elm, it's going to go through these distinct stages of its bark. It's going to be a lot more smoother when young. It's going to develop those squishy scales, and then it'll become deeply ridged and furrowed. I think the Dutch elm disease will just reduce its ability to get to that end stage of deeply ridged and furrowed just because it can't live that long. But if it's a mature tree, even if it has Dutch elm disease, it's going to have the deep ridges and furrows. I only seen a couple of American elm trees that have those that still live, but we have a very mature one that has survived at wood end, and now I see a bunch of its offspring, and they're very squishy scales throughout wood end. They're one of our more abundant trees, actually.
Cool. I had a question that I didn't put in the chat, but since I was tracking questions, I figured I'd ask. I used to think that persimmon bark was just so unique, but now watching your presentation, I can see that there are others like the hackberry. So how do you tell a difference bark-wise between persimmon, hackberry, and the other kind of alligator-like bark?
So the hackberry won't. So in the persimmon, the plates are going to be basically touching each other, kind of as if there's no space for all these plates. The protuberances on hackberry is more what we would think of as like an actual wart. They're not fighting for space. They're they can even be somewhat continuous in fashion. And then they tend to be, and then age too. So the black gum, you won't get that characteristic plated bark until it's a little bit more mature. Whereas on the persimmon, it's going to start very early. And once you see the bark, you can usually be in your mind like, oh, it's one of these three, and then you look at your other features. So if you think it's a black gum, you look for your 90-degree branching. If you think it's a persimmon, you look for those silhouetted buds. And the hackberry, it's going to be a different color. It's going to be more of a lighter gray bark color comparative to our dark color of our persimmon and black gum. You can't just use one feature. You know what I'm saying?
Janet Siddle says, does anyone eat the sweet gum seeds?
Well, I am not familiar with that, and I will never tell anyone to eat anything unless I'm 100% sure. So please look up before trying anything. But there are a lot of edible things I mentioned today. The persimmon, the blueberries, the service berries. I can't wait until June when the service berries come out. But I am not familiar with sweet gum.
Do you know if any animals eat the seeds?
I'm sure. I'd be surprised if not. I don't know of which ones though.
Kara Shirk asks, and we did have an answer in the chat box, but I'll give you a chance to chime in too. Are there any distinguishing features for ironwood?
Well, actually, now I have to ask the question. There are two tree species that can be referred to as ironwood. So we're asking about American hop hornbeam Austria virginiana or American hornbeam Carpinus caroliniana, both of which are in the Betulaceae, the birch family, both of which can be referred to as ironwood. So we're talking about the Austria, the American hop hornbeam. They have a very shreddy bark. It's kind of a I would describe it as like a light tannish brown, and it shreds in these fine strips. And they have the catkin flowers, and then their fruit is very akin to what you would see as hops on that herbaceous plant, whereas the Carpinus caroliniana, the other species, what we also call musclewood, will have a very muscly, smooth gray bark, has the same catkin-like flowers, but then the fruits are less hop-like, and the wings of the nutlets, a small, somewhat fruit-like structure that's like a nut, will be lobed similar to that of a maple leaf, like 3-lobed. It doesn't look like hops. So those are like kind of features you can look at throughout the year. So yeah, flowers, fruit, and then bark year round. So that's why I don't like to use common names. Because ironwood is commonly used for 2 different species. I actually learned in one of my classes recently that there are a lot more species that colloquially is called ironwood throughout the United States.
That's helpful and a good reminder too, that we should all be focusing on the scientific names if we can.
We can, yeah, there's a lot to remember. And Latin, you produce it, which helps you remember or spell it.
Paul Y says, what is the function of the wings on the sweet gum trees?
I usually relate the wings and those protuberances to herbivory defense. That's why I most likely am to see the winged features on a younger tree, though I have seen very mature trees with every single stem winged, and I'm not really 100% sure why, even on a mature tree, it would continue to produce these wing-like features. So I don't know if it's even more on the genetic side of things that it can produce it more consistently on some trees rather than others. But I always relate that structure to herbivory defense, especially at younger ages and smaller growth forms like shrubs.
Excellent. I want to thank everybody in the chat box for answering questions that we weren't sure the answers to, like who was eating all the sweet gum balls.
Yeah, I saw that. I saw Tohi in one of them. So that's a good one to eat, the sweet gum seeds.
Noel Talcott says, this is a rather general question. Shagbark hickory tree year nut cycle?
3-year nut cycle, is that what the question was?
Tree year nut cycle. I guess maybe what is the hickory tree nut cycle?
It's similar to that of our other hickories. I'm pretty sure they produce nuts on a yearly basis. So you'll usually have nuts defined on the ground. But I'm not 100% sure on the cycle. I just kind of know what they look like when they're done growing. And of course they have, different from our other hickories, a very shaggy bark that doesn't just peel at the bottom, but also peels at the top of the tree.
And Ramana Campos says, are the bean-like structures of the catalpa the fruit with seeds inside? If they hang all winter, when do they fall and how do the seeds get dispersed?
So I guess in terms of how they fall, I would assume that at some point they're just getting knocked off by wind as the connection to the stem weakens. I'm not sure how they are dispersed, but those bean-like structures can have up to 6 or more seeds in them. You would think it would be more with how long they are, but it's usually about 6 seeds are found with them, and they're a bean-like capsule. I know they're also called cigar trees too in some places. I'm sure something eats it, but I don't know the dispersal method within them.
Pauline O'Hare asks, do Norway maples prevent the growth of other trees or plants around them?
Are they allelopathic? So I know allelopathic tree or species include honeysuckle and black walnut. Black walnut's allelopathic, secreting juglanone into the soil to restrict growth of things around it. I'm not 100% sure of Norway maple. I have seen lots of natives and non-natives growing within the area of a Norway maple. I'm not sure if that's just because they're resistant to it or if it's because they are not allelopathic. So I can't answer that with 100% confidence. And I was also seeing in the chat as they popped up that the catalpa seeds are wind dispersed.
And Colt Gregory asks, which of our local maples produce maple syrup?
Oh, maple syrup. Well, sugar maple, of course, is going to be the big one that's going to produce syrup. And I know box elder can be used at times. They're just not as sweet, and probably red maple. I know sugar maple is the big one. We have a few at Wood End. I've never thought to tap them, but I've always been intrigued by the process. I've been cutting Japanese maples recently, and I forgot about the time of year and just seeing the sap flow and flow and flow. And apparently you can use Norway maples too. And I'm sure I should just tap one of those. I don't care about harming them. And there's plenty of them at Wood End.
Yeah, it's great to see that you can use Norway maples too.
Yeah, it doesn't seem to harm the tree too much since they do it pretty consistently on sugar maples for many, many years. So I don't know what the harm ratio is for them.
Yeah. I see a comment here that just says, talk about Dawn Redwood.
Dawn Redwood, Metasequoia glyptostrogoides. Very interesting tree. It's very popular in landscape settings. I know that it's not native here. I'm pretty sure it is Western species. But I do see it a lot in the landscape. Where are you native? It's in the cypress family, Cupressaceae, so it's very closely related to our junipers. So it's not a what we call a true cedar. I'm trying to find where it is from. I think it's from China. Yeah, but they're a very cool looking tree for sure. There's a few at University of Maryland. Oh, distribution goes country of regional origin, central and western China.
Excellent. Peg Nemoff asks, I was told by Tree Baltimore that the baby sassafras they gave me was monoecious,
Monoecious.
which means having both male and female.
It does have, yeah, male. So monoecious means male and female, same house, is what the Latin root is. So same house, both male and female on the same individual. Dioecious, two houses, male and female on separate trees.
How do they know if that's accurate information?
Well, depending on how old it is, you can wait for it to flower in the spring. If it's not old enough, you can't tell. If it's not producing flowers, there's no way to tell, at least in my experience. And then when it does flower, you can look for the particular male or female structures. The male flowers are going to have the stamens with the anther that has the pollen, whereas the female flowers are going to not have stamens, but they're going to have this very globular pistil with the long, I forget the structure name, but a thing to catch the pollen as it's flying through the air. So you can look for those and those features in the flower. I have always been familiar with Sassafras dioecious, but I do know that some of our dioecious species can sometimes produce hermaphrodite species or individuals, but if they do, the male and female flowers are going to be separate on the tree. So you'll have a female flower and then somewhere else you have a male flower. They're not going to, the structures aren't going to be held together in what we would call a perfect flower like that of our tulip tree, which has male and female parts all in one flower.
Hey. Neil Gormley asks, do you use a different type of form, like the shape, like how straight or twisty a tree might be, as a way to ID? Examples other than a tulip tree?
I guess if I see something that has very pendulous twigs, my first thought would be willow. If you're in a landscape setting, you can see lots of different types of cultivars that we've bred to show off some sort of feature or function. So we get the drooping, like I just mentioned, which is the pendulous variety. But then you can have dwarf ones. There's lots of them, but in terms of growth form, I mostly just look at tree, shrub, vine, and then go from there. I'm trying to think of these features on the spot. The tulip tree, they have very straight branches and they tend to curve up towards the top. So you can see just kind of the shape of the branches as they're reaching for the light. Otherwise, those are the only examples I can think of off the top of my head.
Steve Lonker asks, you point out the diversity in bark morphology and other traits between species. If you take a community-based view, do you see adaptive similarities of bark between different species depending on water storage and biomechanics based on wet versus drier habitats?
Interesting. I'll just give a short answer is I have not looked at bark or thought of bark in that way. So no, I have not made any connections in that way for bark and dry versus wet conditions. I do know that bark can be pretty characteristic even on the family level. So for example, bark of those in the cypress family, the Cupressaceae, or bald cypress, or junipers, they tend to have a very shreddy bark. Even if it's occurring in a dry or a wet habitat, it's a pretty similar, consistent feature throughout all of the trees within the Cupressaceae. I do not think I've observed a difference because like I think of black gum and persimmon, I'll give as an example. They both have a very plated bark. Black gum more common in floodplain. Persimmon I've seen more mountainous and can be more upland, though having a very similar bark feature. It's the only example I can think of at the moment, but I haven't thought of tree bark and its occurrence in different habitats in that way. But I'm in a plant physiology class right now, so if I learn anything, I will let you know.
And we have one last question. More might come in though. Amy Garcia asks, I've seen trees in a nearby woodland with bark that has a leopard print appearance. Is this a fungus or a disease? The trees seem to be okay, and the pattern appearance hasn't gone away.
Huh. I can't say I have experienced a tree that I would describe as having a leopard print pattern. So no, I do not know. I'm trying to imagine what it looks like in my head. And I couldn't begin to tell you whether it's bark that's supposed to look like that or if it's fungus or disease. So yeah, it's hard for me to say with confidence anything.
Might it be lichen on the bark?
It could be. I can't say with confidence. I'm still trying to picture like what it looks like in my head. And I just got a tree that's like looks like it's like wearing like leopard pants.
Could it be a sycamore?
It could be a sycamore, depending on its age and what the colors. Especially when it's older, you have the more consistent white inner bark, and it's not as splotchy, but it's definitely more splotchy on a younger tree.
There is an actual leopard tree,
Oh, interesting.
Australia or something.
Ah,
So
yeah. All right, we have a note that dawn, redwood, and bald cypress can be propagated by seed. And this person did so a couple of years ago. Well, good luck to you on that. I would like to
Wonderful.
thank Bradley Simpson, as so many as dozens, if not hundreds of people have done in the chat, for taking so much time to put this wonderful presentation together and then to answer so many questions. Bradley, you've done a fantastic job of educating us. I think everyone had things to take away from this evening. And
yeah, thank you for hosting this and providing it for on such a wide base. This is the most people I've ever talked to at one point. And I was glad to talk about some of the things that we offer at Audubon Natural Site as well. So if you're ever in the Chevy Chase area, please come visit. We just completed a huge restoration. We planted over 10,000 plants. It looks pretty spectacular in my obviously unbiased opinion. And then email me if you have any questions regarding tours or walks or other programming at ANS.
thank you.
I can't plug the Natural History Field Studies program too much. It's a wonderful opportunity to go and spend, let's say, 8 weeks and several field trips with somebody as wonderful as Bradley is. So do consider taking a look at that. And Woodend is getting plugs, as are you. So yeah, and Scarlet Swan says, if only I could remember everything. Well, that's why we keep coming back for more. There's always much to learn. So thank you very, very much. I think we'll go ahead and close out our meeting now. It's 8:30. Again, deep thanks to Nancy Veers for taking the time to set this up, register everyone, and help in the background, as has Renee and Margaret Fisher and so many others. So we're very grateful that we have this community of learners and community of people who care deeply about our natural features and our woodlands.